Hey, fourth grade. I just got done videotaping a lesson on how to solve for unknown angles. And I thought to myself, I better take it back a step and talk a little bit on how to estimate angles. I think that's one of the more important skills to be able to do as a fourth grader when it comes to angles. It helps you check to see if you got your answer correct. If you got the answer 22 degrees and you look back towards your estimate and they match up, you should know that you probably did the problem correct. Most of this little lesson is going to deal with the vocabulary that goes along with lesson 8.2. And I have a little bit of that in the next video as well that I've attached to this one. But I'm going to start with just going through the different kinds of angles and what they might look like. First angle, the smallest angle is called an acute angle. I'm going to write them all down on the left-hand side, and then we'll go through each one by one in a second. It has the word cute in it. And I think cute things are usually small, and this is the smallest type of angle, acute. We have a right angle. We have a little bit bigger than that would be an obtuse angle. And in third grade, I think that these are probably the three that you stick with most often. Obtuse used to be your big one for you, and I used to say it like this in my class, obtuse. And it gets you in the mindset that's bigger than a right angle. But then in fourth grade, we introduce a straight angle. And finally, the biggest one we can have is a reflex. Okay, so here are your different types of angles: acute, right, obtuse, straight, reflex. I'm going to start with acute and work my way down. Now, acute can be anything that is greater than 0 degrees, x being the acute angle, but it has to be less than 90 degrees. That being said, it could be 0.01 degrees, and it's still acute because it's bigger than 0, but it could be 89.999999 degrees and still be acute because it's a little bit less than 90. Once it hits 90, it becomes a right angle. Right angles are always 90 degrees. They could be upside down 90. They could be right side up 90. They look like perfect L's. So I'm going to break out these two little base 10 blocks that I have here and show you what these two look like. An acute angle is anything bigger than 0. So that's an acute angle right there that I've made with them. And it goes, these are acute, acute, acute. See this angle I'm making between them? Acute, 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 acute. When it hits a perfect L, it becomes a right. Doesn't matter if I turn it this way, that's still a right angle, or this way or that way. As long as it's an L, it's a right. Moving down to obtuse. Obtuse is a little bit more than 90. It's anything, excuse me, I'll write it like this. Any angle that is more than 90, but less than 180. Here's a 90, so this would be considered right. If I open up a little bit more, it's obtuse. It keeps going, 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 obtuse, obtuse, obtuse. This angle here is obtuse, 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 obtuse until it hits a straight line, which is your straight angle. This would measure 180 degrees. Okay, and once again, that doesn't matter if it's faced vertically like this, straight up and down, or horizontally, it's still 180 degrees. And finally, the biggest type of angle that we have is the reflex angle. And this one has the word flex in it. I usually have my students put up their arms and flex as hard as they can because the harder you flex, the bigger your muscles become, the biggest angle, right? So, and a reflex angle is anything that is greater than 180 degrees, but less than 360 degrees, because a 360 degree angle would just be a full circle, which I'll explain that in the video I attached to this. So a reflex is anything bigger than 180. Once again, here's your 180 straight angle, straight down the side, but if I open it up just a little bit, Now, I want you to see this side of it. This would be considered a reflex angle. On the other side, you might be noticing, hey, Mr. Shorter, there's an obtuse angle on this side. Yeah, because this side's the reflex, and then its complementary angle over here will get you back to 360 degrees, which is the full way circle. But what I'm talking about, this side of the angle. And a lot of times on these reflex angles, they label them like this. This might look like an acute angle to you, but if they label this side, well, then that's a reflex angle because it's more than a straight. It's all the way around. It's almost approaching a full circle again, which would be 360 degrees, which in reality you could write down as a type of angle because it's 360 degrees. And then once you pass that 360 degrees, you can actually have angles that exceed 360 degrees, and then they keep going and going and going, because if you think about a basketball player dunking a ball, let's just say he jumped up and spun around twice. Well, then that's more than 360 degrees, isn't it? Same thing with a snowboarder. He could jump up and spin around 4 times. That's 4 360 degree angles added together in one jump. So you can have more than these, but this is what we're focusing on in 4th grade. When you get your answers, check back to see, does it look like an acute angle? Does it look like a right angle? If I got an answer that was obtuse, does it look like an obtuse? Does it look like a straight? Does it look like a reflex? Or could it possibly be a 360 degree angle? Those are the types of angles, and this is a kind of a little chart to show you where they fall under. And I'm going to talk about solving for unknown angles. I'm going to reiterate what I said earlier about different types of angles. That way it makes a little bit more sense. Now, I like to start off by talking about your circle, which we talked previously. That's a 360 degree turn. If we chop it up into 4 different sections, it helps you actually see those angles we previously talked about. Starting with 0 degrees, if I didn't turn at all, and all the way to 90 degrees, which is a perfect L. Any angle that falls between that 0 and 90, starting at 0, and if I open, all of these angles that I'm making right now with my base 10 blocks would be considered acute angles until I get to that perfect L, which makes a right angle. So your green space here would be considered your acute. Those smaller angles, they look like this. Could be almost a perfect L, or they can be really teeny tiny too. It doesn't matter which way they face as long as they're labeled appropriately. Now I'm going to keep going. Once you hit that 90 degree angle, the perfect L, no matter which way it's facing, is called a right. Once you pass the right, you keep going into the brown area that I'm drawing here. So we have acute, right. Passing it, we have what's called your obtuse angles, all the way until it becomes straight. But once it's straight, it's no longer obtuse. So anything in that brown area is called obtuse. Make sure you can see it. Obtuse. Okay. And that's, I'm not going to label the degrees at this moment because I did that on the previous video, but once you hit that straight line, you get what's called a straight. Okay. So, just to go back and check through these things, 0 degree, 1, 2, 3, 4, 5 degrees, 6, 7, 8, 9, 10, all the way until you hit 90 degrees, you get a right. Past 90, you get to the obtuse angles. Once you hit a straight, you're at 180. I'll label that one because that's an important one. 180. And finally, on this other side, I'll put it in orange. Everything on this back end here of the circle is called a reflex angle. One where you flex your arms as hard as you can because that makes your muscles big, just like the biggest angles there are. Once you pass a straight line, everything on this side becomes a reflex. So acute, right angle, obtuse, straight angle, straight line. Once you pass that, you have your reflex angle. Reflex, 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 all the way until you get back to a 360-degree turn. Now, you might be thinking to yourself, Mr. Schroeder, why is this chopped up into 4 pieces? I want to show you that. Because there are angles at each one of these 4 stations, kind of, that we need to memorize. From here to here, the first one would be 90. We have that one pretty well memorized by now. The second quarter of the turn gets me to 180. The third quarter of the turn, the one that you might not know, is actually 270 degrees. So, like we talked about in the previous little clip, from 180, once I pass 180, I'm into the reflex angles. The 3/4 turn, kind of the halfway through the reflex, is 270. And then all the way back to the top, once you've turned all the way around, you've done a 360, just like a snowboarder who jumps up and spins all the way around. It's called 360. These are, this is a good little visual for the review of different types of angles. But now I'm going to talk about how to solve for missing angles. If you want to pause the video on that picture I just drew, you definitely can to take a little review. Here we go. Solving for different types of angles can be challenging if you don't know that vocabulary, but now that we have the vocabulary, it should be a little easier. This is a straight angle. If I were to cut a piece off, and let's just say that that piece was 40 degrees, how big would X degrees be? I know that it was straight. That's 180 from here to here. That's what I started with. If I get rid of what I do know, 40 degrees, it'll leave me with 40 plus something gives me 180, or 180 minus 40 gives me, 180 minus 40 gives me 140 degrees. This is where that estimation comes in. I think that X equals 140. Using what I know about my vocabulary, does this look like an obtuse angle to me? Yeah, it does, because I know it's bigger than a right, but less than a straight. It's definitely an obtuse. This would be my right in comparison, but it's a little bit more than that, a little less than 180. I'll keep going. You might have a time where you have a 90-degree angle, and they broke that into 2 pieces. And the small chunk was 20 degrees, and they want you to find out what Y degrees is. Same process. I know I started with a right angle, which is 90 degrees from here to here. And I can get rid of my 20 degrees, which is just this little chunk, because if I add these chunks together, it gets back to 90. So 90 minus this little chunk will give me the degrees that I'm missing, which would be 70 degrees. Once again, is this an acute 70-degree angle? I'll use my estimation skills. Yeah, it's more than 0 and less than 90. Got it. Moving on, last type of problem I'll show you, before my video might get too long, is where they, an idea where they might cut an angle up into a couple of pieces, but you still use the same process. If I have we'll go back to the straight angle, and they chop it up into 3 different angles. This chops it into 2, and this chops it into 3. Sorry, my markers are going dead. But let's just pretend that these angles are the same. Angle X, angle X. And you have a 90-degree angle right here in the middle. Well, how do we solve for X? I know what we started with, a straight. Vocab comes in handy again. This was a straight. It started at 180 degrees. What do I know that I can get rid of? I know that one part of it, this is a perfect L. You might have to turn your head to see that. It might be a little off, but I can get rid of the 90. That leaves me with 90 left. Well, is X degrees equal to 90 degrees? That doesn't look like a perfect L. Oh, it's because there's 2 of them. And once I take the 90 and divide by 2, I'll be able to solve for each X. 90 divided by 2, half of 90 would be 45. So each X must be 45 degrees. The trick is knowing your vocabulary and then going back and saying, does my answer make sense?